In this video, I'm going to explain how to use right triangles to find resultants. Sometimes when you're adding vectors, you have two vectors that are perpendicular to each other. When that happens and you're only adding those two vectors, the resultant will be the third side of a right triangle. So as an example, we have this little person here, physics person, is going to go from this point to this point. And let's suppose that physics person goes this way. They walk over to the elevator and then they ride the elevator up to the top. And we want to find their total displacement. So the first displacement that happens goes from here to here. The second displacement that happens goes from here to here. So you can see that we're really adding two displacements together to get the total displacement, which goes from here to here. So this would be the resultant, or the total displacement. This is the first displacement and this is the second one. In this situation, the two displacements that we're adding together and the resultant form a right triangle. So we can use the properties of right triangles to find this resultant. This gives us a mathematical way to find a resultant, which is sometimes faster than making a whole graphical drawing that's to scale. So let's suppose that this distance here is, let's say this is 12 meters, and then the height from the first story to the second story, the tall building here, is 6 meters. And we want to know the resultant. Well, this is a right triangle, so the sides of a right triangle are related using the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. In this formula, the a and the b are the legs, and the c is the hypotenuse. So the hypotenuse is opposite the right angle. So this is side C, and these, either one can be A or B, it doesn't matter. Okay, so in our example, the resultant is side C, and either one of these could be A or B. So let's substitute our values. So for A, I'm going to put in 12 meters. For B, 6 meters. And that's going to equal the resultant squared. So now it's just a matter of calculating. So 12 squared plus 6 squared gives us 180 meters squared. So to find the actual length then, we just need to get the square root, which is 13.4. Okay, so the magnitude of physics person's displacement, the magnitude is the length of this resultant, which we've just calculated. The magnitude is 13.4 meters. But a displacement has a direction as well as a magnitude, so we need to know the angle of this vector. So let's make a coordinate system, or we can just describe the angle, I suppose, as how much above the horizontal. So I'm going to call this angle theta. This is the angle that I want to find. In a right triangle, the sides are related by some different functions. And one of those functions is the tangent function. The tangent of angle theta in a right triangle is going to be equal to the opposite side, or whichever leg is opposite the angle, over the adjacent, meaning the side that is the leg of the triangle that is adjacent to the angle. In this triangle, I'm doing this angle, so opposite this angle is over there. So this is the opposite side. Adjacent is the leg that's touching the angle. So this is the adjacent. So now what I need to do to find the angle is substitute the opposite and the adjacent lengths. So the opposite is 6 meters. The adjacent is 12 meters. So that gives us that tangent of theta equals 1/2, or 0.5. To find the angle, we have to do the inverse tangent. So from here, the actual angle is equal to the inverse tangent of 1/2. Okay, so once you get this value, you use your calculator, you do the inverse tangent button. So here's how it works. You put in 0.5, then find inverse tangent. Usually you have to do a second or a shift button to get the inverse tangent, and out comes the angle. So 26.6 degrees is theta. So right here. Okay, so the resultant displacement of physics person is this displacement plus this displacement. Because it's a right triangle, we can use the Pythagorean theorem to find the length of that displacement, the total displacement. And we can use the tangent and the inverse tangent to find the angle. So the final displacement of the person is 13.4 meters at an angle of 26.6 degrees above the horizontal.